Hi, this is a video where I'm just going to do one problem about combustion analysis. So this is something that falls under the 1.3 elemental composition. We can analyze compounds and figure out how much of the elements are within them to be able to figure out then the empirical formula of the compound. So with this kind of problem, combustion analysis, you literally burn some kind of a compound that contains carbon, hydrogen, and then maybe nitrogen or other elements. And then we can measure the amount of carbon dioxide and water. We're assuming that all of the carbon in the original compound, all of the carbon dioxide comes from the original compound's carbon, and all of the water, the hydrogen, comes from the original compound's hydrogen. So let's just do this example together. So here we have a compound, carbon, question mark, hydrogen, question mark, and nitrogen. And they're telling us that, it's a combustion. You don't have to write out the reaction, but sometimes it's helpful to visualize. So they're telling us that we have a 35.0 milligram sample of the compound, and we're getting 33.5 milligrams of carbon dioxide, 41.1 milligrams of water. And what we want to do is start with the water and the carbon dioxide and then work our way to the nitrogen. So the first thing I'm going to do then is determine how many grams of the sample are carbon. So I'm going to start with the carbon dioxide, and I'm going to convert this to eventually to grams of carbon. So I know I can easily get to moles of carbon dioxide. And then I know that there's 1 mole of carbon for every 1 mole of carbon dioxide because of the formula. And then I know that there's 12.01 grams of carbon in a mole of carbon. So this gives me 9.14, 10 to the negative third grams of that compound are carbon. So we are going to need to use percent by mass here because you'll see later that that's how we're going to be able to determine the amount of nitrogen. So I'm going to calculate that right away. So my percent carbon is just going to be my grams of carbon over the total sample mass. And I did convert this into gram. So it's 26.1% carbon. So that is our carbon calculation. Now let's do our hydrogen calculation. So assuming all of the hydrogen in the water came from the original compound. So I start with my 41.1 milligrams of water. Oops, I'm going too fast. First, I got to get into gram, and you don't have to show this if you don't want to. Whoops, can't, but I like to. Okay, so 1 mole of water is 18.02 grams. There's 2 moles of hydrogen for every 1 mole of water. And then hydrogen has a molar mass of 1.01, which gives me 4.60, 10 to the negative third grams of hydrogen from that compound. So again, I'm going to calculate the percent by mass of hydrogen by taking my grams of hydrogen divided by the whole sample mass. And then I get 13.1% hydrogen. So the reason I did percent by mass is because of the nitrogen. We don't have a compound that we can, that we analyze to correlate back to the nitrogen. So I know that the percent of the hydrogen, the carbon, and the nitrogen should all add up to 100. So my percent of nitrogen then is going to equal 100 minus the percent of carbon plus the percent of hydrogen. So 100 minus 26.1 plus 13.1. So my percent of nitrogen is 69.8. So now that I have those 3%, this is like any other empirical formula question where you're given the percent by mass of the elements. So now we're going to assume that we have a 100-gram sample. So really, that just means that my percents become grams. Then we're going to convert to moles, divide by the smallest moles, and then, if needed, multiply to get whole numbers, and then write our empirical. So if you want to work ahead of me and pause it, feel free. But I'm going to start. So I have 26.1 grams of carbon because I had 26.1% of a 100-gram sample. So 2.17 moles of carbon, 60.8% or grams of nitrogen. And then hydrogen, 13.1%. So once we get to this point, we want to divide by the smallest number of moles. So carbon, we're going to be dividing by 2.17. So there's going to be 1 mole of carbon. Nitrogen, dividing by that same small number. So we'll have 2 moles of nitrogen. Remember that these might not be exactly whole numbers, but if they're close, you can assume they are. And then if they are 0.5s, you would multiply by 2. And there's, things like what to multiply by to get whole numbers is in your packet. So lastly, we'll do hydrogen, which is 13 moles over 2.17. So this one is like 5.99, but close enough to 6. So then our empirical formula is just going to be CH6N. So I hope that helps you with combustion analysis questions.